Alright, hello math fans. Today what we're going to do is we're going to use some of our knowledge of double angles, which we just learned that, and we're going to do some more verification of identity. So we're going to be proving that the left side is equal to the right side. So let's start out with an example here. If I have sine of 2x over sine of x is equal to 2 over secant of x. Alright, the more difficult side almost always is going to be the double angle, because it's really difficult to form into a double angle, but it's easy to expand from a double angle into something without a double angle, into a single angle. So what we're going to do is you should recognize that right away, and then you should say, okay, sine of 2x. So I'm going to work on the left hand side. So sine of 2x is 2 sine of x cosine of x over sine of x, and that cancels. So we have 2 cosine of x, which then of course is just the reciprocal function. I can write that as 2 over secant of x equals 2 over secant of x. So pretty easy. Okay, well, let's try another one here. 2 tangent of x over sine of 2x, and that equals secant squared of x. So once again, well, the left side is definitely more complicated because you have double angle and you have a fraction. So the first thing I'm going to do is 2 tangent of x over 2 sine of x cosine of x. And remember, if you don't see anything else to do, always do sines and cosines. So we're going to do 2 sine of x over cosine of x over 2 sine of x cosine of x. Now, not a bad thing to do is actually change this into division. Well, we have it in division, change it into multiplication. So we're going to have 2 sine of x over cosine of x. And if you want to put that as a fraction there, so it's times 1 over 2 sine of x cosine of x. So we have the sines cancel out, the 2's cancel out, and we have 1 over cosine squared of x, which is secant squared of x by the reciprocal function, and that's equal to secant squared of x. And we prove that identity. Okay, so let's try a couple more. We have secant squared of 2x minus 1 over secant squared of 2x equals sine squared of 2x. Well, you don't necessarily recognize the secant squared of 2x, so you're like, well, geez, what do I do? I don't know. We didn't learn double angle for secant squared of 2x. But what you can do is, remember, it's got one denominator. So definitely we're going to work on the left-hand side, but you can split that up. And it's secant squared of 2x over secant squared of 2x minus 1 over secant squared of 2x. Well, of course, that just cancels to 1. And this, I can actually, it's just the reciprocal of cosine. So it's 1 minus cosine squared of 2x. And once again, we don't really even need to do anything with a double angle, because 1 minus cosine squared, this is basically from the identity sine squared plus cosine squared equals 1, or 1 minus cosine squared of x equals sine squared of x. So I can literally just write sine squared of 2x, and then that equals sine squared of 2x. So we're done with that problem. Okay, that was pretty mellow. All right. So let's try another one here. Cosecant of negative x minus sine of negative x over sine of negative x equals cotangent squared of x. Okay, definitely left side more difficult. Remember a lot of the negative angle identities. So cosecant goes with sine. So as sine of negative x is negative sine of x, same thing with cosecant. So I can rewrite that as negative cosecant of x, and then that's minus, again, the sine of negative x is negative sine of x, so it's minus a negative. I'm going to show my work here. Over negative sine of x. So I can write that as negative cosecant of x plus sine of x over negative sine of x. And I can actually split this up. So I can write this as negative cosecant of x over negative sine of x plus sine of x over negative sine of x. Alright, so I can simplify a little bit more here, and I can write, first of all, the negatives cancel here, and I can write 1 over sine of x over sine of x over 1 minus 1, because the signs cancel. So I can rewrite this as 1 over sine of x times 1 over sine of x minus 1, which is 1 over sine squared of x minus 1. And then 1 over sine squared of x is cosecant squared of x minus 1. And then again from our identity, cotangent squared of x plus 1 equals cosecant squared of x. I move the 1 over, and this is then an identity. So I can write this then as just cotangent squared of x equals cotangent squared of x. And we're done with that identity. Okay, and here's another example. Sine of theta minus cosine of theta quantity squared. And that's equal to 1 minus sine of 2 theta. Now in this case, I think the left side is actually more difficult, because it's really difficult to get something into, to have it look like the left side. It's in quantity squared, and really what I need for this sine of 2 theta is I really need 2 sine of theta cosine theta. So you could probably do it both ways. I'm going to actually choose to work on the left hand side. So I'm going to FOIL that out, and I'm going to get sine squared of theta minus 2 sine theta cosine theta plus cosine squared of theta. Well, it's nice because here we are, sine squared plus cosine squared is 1. So it's 1 minus 2 sine theta cosine theta. And there we go, guys. That's a double angle, so 1 minus sine of 2 theta. And that's equal to 1 minus sine of 2 theta. We're done with the problem. Okay, so let's try another one here. If I have cosine of 2x equals 1 minus tangent squared of x over 1 plus tangent squared of x. So definitely the right-hand side is the more difficult side. So what we need to do is we need to get this cosine of 2x. So let's write on the side here, cosine of 2x. Somehow either cosine squared of x minus sine squared of x, or 2 cosine squared of x minus 1, or 1 minus 2 sine squared of x. if we can get that right-hand side to look like any one of these three things, then we're all set. Okay, so first thing you should recognize is the bottom right there. 1 plus tangent squared of x is going to be secant squared of x on the bottom, and the top is 1 minus tangent squared of x. Alright, well we have one denominator, which is actually really nice. So what I can do is I can write things in terms of sines and cosines. Actually, I want to split it up first. So it's 1 over secant squared of x minus tangent squared of x over secant squared of x. So this one right here it's just reciprocal. So that's going to be cosine squared of x, and then minus sine squared of x over cosine squared of x over 1 over cosine squared of x. So I can rewrite that as cosine squared of x minus, and then that's just sine squared of x over cosine squared of x times cosine squared of x over 1. So that cancels, and you wind up getting cosine squared of x minus sine squared of x. There we go! Double angle. It's actually this first one that I wrote here. So now I can say that's equal to cosine of 2x equals cosine of 2x. And we're done. Alright, very good. Let's try another one here. Sine of 2x over 1 plus cosine of 2x equals tangent of x. Definitely, again, the left-hand side, more difficult side, obviously. What I want to do now is I need to just break things up. So sine of 2x is 2 sine of x cosine of x. And then the denominator, I either write it as, obviously it's one of three forms I can write it as. What I'm trying to do is, if I can get it in terms of one, either sine, well obviously sine or cosine, but if you think about it, I've got a 1 plus here. So I'm just going to write the 1 plus right away. Now it would be nice, I have two denominators. If I can get that to be one denominator, that's what I really want, because then things will cancel out really nicely. If I keep it as two denominators, it's not good. So what I want you guys to think about is, if I have 1 plus, I need something where it's going to be something with a minus 1, because then the 1's cancel out and I have just one denominator. So the only identity that's going to work out here is 2 cosine of x, or cosine squared of x minus 1. That's the identity that I want to use. So it's 1 plus 2 cosine squared of x minus 1. Because now the 1's are going to cancel out. That's pretty sweet. And actually then the 2's cancel out. And actually the cosine cancels out on top. And I wind up with just sine of x over cosine of x, which is tangent of x. So you can see, if you choose the right identity, especially with cosine, is kind of picking and choosing, you can make things a lot easier for yourselves. Okay, so let's do another problem here, and I want to simplify using only cosine. And it's cosine of 3x. Well, we didn't learn anything about triple angle, but we can apply some of the things, kind of like when we learned double angle. We really didn't have to do too much derivation. We basically had to do, double angle was like for example, cosine, it was just cosine of x plus x, and then we actually use our sum formula for cosine and broke it up and derived cosine for double angle. So we're kind of going to do the same thing here. This is the same thing as cosine of 2x plus x. So I can write this out using my sum for cosine. That's the same thing as cosine of 2x, cosine of x, opposite sign, sine of 2x, sine of x. And then what I can do is each one of these are double angles, and now I can apply my double angle formula. So I'm going to just leave it in terms of cosine here, and it's going to be 2 cosine squared of x minus 1 times cosine of x minus 2 sine of x cosine of x sine of x. Alright, so let's distribute that. I get 2 cosine cubed of x minus cosine of x minus 2 sine squared of x cosine of x. So remember, I want everything in terms of cosines. So we need to convert that into 1 minus cosine squared of x. So it's going to be 2 cosine cubed of x minus cosine of x minus 2 times 1 minus cosine squared of x cosine of x. So you got 2 cosine cubed of x minus cosine of x, and I could put that 2 together. That's 2 cosine, so it's minus 2 cosine of x, and then it's negative 2 and the cosine squared and the cosine, so it's actually plus 2 cosine cubed of x. And we combine like terms, and we get 4 cosine cubed of x minus 3 cosine of x. And there we go. That is a cosine triple angle. You don't need to memorize that, but you should know how to derive that. I can even give you cosine of 4x or cosine of 5x, and you'd have a lot more work to do. I can give you any amount. You just have to keep breaking it up and simplifying. It's basically a lot of algebra that's involved here. So anyway, those are the examples. I hope you learned something here, and that's it. Have a nice day. Bye.